All right. Let's go ahead and start. Good morning. So my name is James Pennick. I work with Verizon Media. This is Greg Waynes. He's with StarlingX, or Wind River, I should say. StarlingX. And this is a creaky stage. How about I stand there? We're going to start out, I'm going to talk, so we've both been working closely with the Edge Working Group. We're going to start with, I'm going to cover what our MVP, Minimum Viable Product Reference Architecture is. And then after I go through that, Greg is then going to talk about how StarlingX actually took this architecture and actually built one of them out, and they made it real. So this started back at the Denver PTG 6 months ago, I think it was 6 months ago. And there was a large group of people trying to figure out what to do with Edge. The Edge Working Group is running it, and we sort of distilled down after talking to a lot of the different Edge deployers in the room, like what are the things that you actually need to run an Edge. So when you talk about Edge to people, there is quite a lot of opinion about what Edge means. And there's also quite a lot of opinion about how you actually run an infrastructure. So we tried to take what are the general use cases, the most common examples that you would find in an Edge deployment, and let's build two MVP architectures around that address the majority of those use cases. We're not trying to handle every corner case. We want to capture the general use cases. So the first thing we did is we decided to define what Edge means. So Edge can broadly be broken out into sort of three categories. So you have a large centralized data center, which is a pretty traditional thing most of us are familiar with. You also have a large or a medium edge site. And this edge site, Edge is about latency, is I want to move the data closer to the consumer. Now, in which case the consumer could be a mobile device, it could be a laptop. CDN is one of the original examples of an Edge deployment or an Edge use case. Internet of Things is also similar. You have objects that are generating data and they need to send that up into the internet. And so aggregating that data in an Edge site, the rule about moving things, reducing the latency between the generator and consumer of data is still true. Finally, we have a small edge. And so we'd say that the centralized data centers within 100 is within a relatively small latency to the user, but let's say 10 milliseconds. A medium edge closer to the user, that's going to be more geographically proximate, so let's say that's a few milliseconds. And then a small edge site can just be 1 or 2 milliseconds, right? Trying to reduce that last mile as much as possible. Similarly, we also define that edge sites, the large sites are going to have quite a lot of bandwidth and power available, more racks, more servers, moving more data. Medium edge sites are going to have less power, less bandwidth available. Small edge sites can have far more constrained bandwidth. So we came up with two reference architectures. And with these architectures, we can then say, okay, we have a distilled set of use cases that we can take to the project teams and say, these are things that we need. Architecture number one is an edge infrastructure which allows greater autonomy during outages. And edge architecture number two is cheaper to operate. However, at the cost of during a network partition event, there will be less ability to manage resources until that event has been healed. So it's more autonomy with a higher operational cost, lower operational cost with less autonomy. Common to both cases, we wanted to solve the problem of how do we manage identity in these sites? How do we manage the ability to actually go and just provision resources at all? How do we identify ourselves? So common to both architectures is this federated identity model. And this model uses a identity provider. It could be a number of different things, OAuth, SAML, whatever you want to use. You have an identified identity provider. And in this model, you go to the identity provider, you pass whatever your password is. This IDP, by the way, could also be another Keystone instance. And you get a token in return. And so in this case, user Jane, she calls the IDP, she gets her token. She then goes and she calls Openstack with that token. She would call Keystone in the large data center side or even the medium side and request to create an instance. Keystone would validate her token and would actually, on the fly, as it validates her token, would look at the token and say, I see it's user Jane for role member in project foo. It will look and see, does project foo exist? If not, create it. Does user Jane exist? If not, create her user. Does the association for Keystone role member for user Jane in tenant foo exist? And if not, it creates that. By putting those pieces into Keystone itself, we've removed the need to proactively sync her account out to all of these sites. The very act of granting her this access in your identity provider and creating that in that secure root of trust allows her to connect to these sites and have her account automatically created. So we no longer need to worry about how do we deal with circular replication of Keystone databases globally. And it also gives us the ability to say that even if there is a brief outage between the IDP and a far edge site, that doesn't matter because if Jane already has her token, she can still talk to Keystone. In this model, and actually we'll get into this a little bit more, this also allows some resiliency. There are some corner cases we can work with that allow some resiliency in the event that even your IDP is down. So, architecture number one, so this is the greater autonomy at the cost of a little more operability pain architecture. So in this model, in your centralized data center, you have identity provider, you have a Keystone instance, you have your Glance API and registry. In your medium site, this is actually where you're running the bulk of your control plane. So in all of your large edge sites, you have a larger control plane. So in these sites, you can deploy compute instances, you have another copy of Glance, you've got all of your storage stuff, telemetry, everything else is there. You then have a small edge site, which runs only Nova Compute, Neutron Agent, basically just hypervisors. The way that I express this model is that you're actually hanging the small edge site off of the large edge site. So the way these small edge sites are geographically highly proximate to your users, let's say, so we're here in Denver, so there's going to be small edge sites all around where we are right now, and there will be a large edge site or a medium-sized edge site, within 25, 50 miles of where we're standing. So the control plane would run in that medium site, and then the local small edge site would have compute nodes. If there is a network partition between that medium or large edge site and your centralized data center, autoscale keeps working. Things keep doing their job, your site stays up, everything keeps going. In the event there's a partition between the small edge and the medium or large edge, your VMs keep running, however, you cannot create or destroy VMs in that case. Also, you don't have to have the small edge, that's just a kind of an add-on. Image distribution in this model. What we're looking at is how do we, again, address the issue of distributing images, right? So if you have a large central data store, and I've got thousands of edge sites, and if I have a tenant that uploads an image, how do I make sure that it's only in the places that it needs to be? So in this case, what we do is the user will upload the image to Glance, and then they would call in the regional data center, so their large data center. They would then call Nova in their large edge site, say, hey, create me an instance. And it would say, create me an instance here in the large edge site. What happens is the system will go, and it will call its local Glance repository, determine whether or not it has the image yet. If not, it will actually go up to the regional Glance API and download the image, and then it will create the instance. In the far edge version of this, if you call Nova in your edge site and you say, hey, boot me an instance in the far edge site, what will happen there is Nova Compute will go, it will call the Glance API in the edge site, which will then check, do I have this cached? If not, fetch it from the regional data center, store it, pass it along to Nova Compute. It can now create the instance. Reference architecture number 2. This is where we actually put the bulk of our control plane up in the regional data center. And each large or medium edge site is basically a Nova cell, is one way to think of it. So in those cases, we run the pieces we need for a Nova cell to run. So we've got placement conductor, as well as the Glance API. And then we can also have compute nodes there. So we run the Neutron agent and the Nova Compute agents as necessary. For the far edge sites, very similar to the case above, you have hypervisors running Nova Compute and Neutron agent. So in this model, the user would call upload an image to Glance. Maybe it's already there. They call Nova in the regional data center. And if they say, Nova, boot me an instance in the large or medium-sized edge, let's see if I can make this a little easier. Boot me an instance in the large or medium-sized edge, and Nova would then drop a message into the queue, goes to the appropriate cell. Oh, thanks. Can you see this better than the dot? Okay. So user calls Nova. And Nova, in this case, would actually drop a message on the queue, goes into the cell. Nova Compute reads from the cell, knows it has to boot an instance. It calls its local Glance API, which calls up, creates the instance locally. If a user wants to boot in the far edge, again, they call Nova in the regional data center. That is passed along through the edge site to the Nova Compute node that's running on the hypervisor in the far edge site. Same thing as before, where it calls back to Glance to get its image. Glance calls back to the regional. So these two reference architectures are very similar. The primary difference is really where you're putting the majority of your control plane. As you can see in this example, if there is a network partition between your large or medium edge site in the middle and the regional data center, you're not going to be able to create instances. Your auto scale is not going to work. So that is the main difference between the two. And now I will kick it over to Greg, who's going to tell you about how he took this vaporware and made it into something real.
All right, thanks, James. I'm just going to swap, let me find, just swap slides. Okay, so yeah, so I work in StarlingX group. We're actually one of the new projects, the pilot projects, started up a year ago. This is just a quick intro to StarlingX, if anyone doesn't know. The code is originally seeded from Wind River's commercial Titanium Cloud product, and now that commercial product now builds on top of StarlingX. And StarlingX is basically like an integration plus project in the sense that it delivers a full, complete OpenStack solution, managing it from kind of day 1 to day 2, like installation and configuration, maintenance, software updates, software upgrades. So kind of end-to-end solution, and then has some add-ons for some higher order orchestration recovery mechanisms and patching orchestration and that sort of thing. The other key thing about StarlingX is that it's really targeted towards edge computing. So there's a number of characteristics of StarlingX that make it good for the edge. For example, it scales very small, so it can scale down to a single server if you have small edge sites. And then it can also scale larger. And then there's some orchestration activities like distributed cloud around managing a distributed set of geographically distributed edge clouds. I'll talk more about that in the next slides. I show some of the major components in StarlingX. The infrastructure orchestration I talked about, our host management is basically our bare metal management system. Configuration management is around managing configuration of both the hardware and the software services that we're running within the integrated StarlingX solution. Service management is just our cluster manager, doing HA clustering activities, as well as just normal monitoring of critical processes and recovering them. Fault management is a very simple alarm management system, manages an active alarm database, and basically provides APIs for all the other StarlingX software to raise and clear alarms. Software management is around doing software update fixes, software upgrades, and upgrades for major versions. And like I mentioned, it's an integration project, so it pulls in, besides the StarlingX software itself, it's pulling in all sorts of other projects, the most important of which is all the other Openstack services, like we pull in all the core Openstack services, and then there's some optional ones that we bring in as well. And then there's other kind of supporting projects that we bring in, like Ceph for distributed storage, DPDK for accelerated networking, and Kubernetes now that we're a containerized solution. Okay, so I mentioned distributed cloud, and the work that the StarlingX has been doing in the Edge Computing Group is really in the context of distributed cloud. And distributed cloud in StarlingX basically implements the reference architecture 2 that James was talking about, where it's, I think we also refer to it as a distributed control plane scenario, where autonomy is a key requirement in order that the edge clouds can be autonomous if network isolated from the central region, or the central cloud. So it's based on OpenStack regions. Each of the clouds, central cloud and each of the individual edge clouds, are an OpenStack region. The central region provides shared services in kind of the classic OpenStack multi-region approach. Like edge clouds can basically use services running on the central regions, like a Glance service or a Cinder service and that sort of thing. But the other main thing that central region does is provide a host of orchestration capabilities. So we have a service that implements deployment and management of subclouds, simplifying that procedure. It's basically our initial step in the kind of journey towards the holy grail of zero-touch provisioning, ongoing journey. We have a configuration portal so that we manage shared configuration across all the edge subclouds. So if you're doing things like setting Nova flavors or setting neutron security groups or something, then the central cloud will distribute that, synchronize that information, distribute it across the edge clouds. Fault aggregation, I mentioned StarlingX had a fault management system, so this basically aggregates the fault data from that fault management service up into the central region so that can be visible. And then patching or software update orchestration basically enables you to deploy a software update with kind of a single kind of command that will easily will iterate through all the nodes of the cloud and really all the nodes of every cloud in the system to actually deploy the update. And then, as I mentioned, then the subcloud regions, they're geographically dispersed. All the communication is over layer 3. It's just the REST APIs related to the orchestration functions that are going between the clouds. And they're running a reduced control plane, but again, it's kind of a sufficient control plane because autonomy is a use case that is mandatory for many of our customers. So the edge subcloud is basically reduced in the sense it's like typically not running optional OpenStack services. Okay, so actually the two activities that we did in the last 6 months with respect to the Edge Working Group for StarlingX was in the context of distributed cloud. And we did two things. This slide's talking about work to synchronize Keystone to basically make it such that identity management is consistent across all the clouds. And the next slide, I'm going to talk a bit about the Glance Edge caching work that we did. So we already, in distributed cloud, I mentioned a configuration portal for sharing configuration data. We already had a synchronization framework that was built to help, to to synchronize data. The framework itself kind of does the bulk of the work with respect to managing the distribution of data, messaging across the clouds and managing the audit of that data. And then really there's just some small service-specific modules that you plug in, an API proxy to intercept data, and an orchestration engine module that really just manages kind of the audit and the specific resources that are getting synced for the service. So anyways, this synchronization framework was API-based, so it used the Openstack REST APIs to synchronize the data. The issue we ran into with Keystone was a number of the resources in Keystone that we needed to get synced for proper identity management synchronization actually were not exposed on the API, and it didn't make sense for us to put it in the API just for synchronization purposes. So we ended up extending the sync framework to support database-style synchronization. And we did look at just using native database synchronization, like that's provided by MariaDB, PostgreSDB. The reason we went this approach was really for future considerations where we are likely going to see a requirement that the edge clouds are not necessarily running the same OpenStack version that the central cloud is. And we needed a hook in the path to basically manage schema and data translations between the central cloud and the subcloud. So we went this way. We did kind of, the objective here was to, again, make the framework do the bulk of the work here. So we tried to write it as generically as possible. Some of the things we did were, we did use the Python SQL Alchemy database reflection package that basically will dynamically learn the schema of a database from the database itself, so you don't have to explicitly manage the schema. So, and then also allows you to kind of do, after doing those learnings, do kind of just standard SQL queries. And then the REST API that we go between that for pushing kind of the database synchronization down to the edge clouds is some of this is still under work, but basically is a generic type API that just basically sends kind of raw DB operations down. So anyways, we were able to, this is mostly implemented and is going to be delivered in StarlingX Release 2 in a few months, and kind of starting to do the testing on that now. If I have time, I can show you a quick demo. Okay, so the second thing we did in the last 6 months in the context of the Edge Computing Group was to look at glance edge caching. And actually the work we did ended up only being spec work. We started out not with this picture. We started out trying to do kind of a caching only solution. Glance already supported image caching, but to be fully autonomous, like if you lost connectivity to the central cloud, you needed to cache the metadata for the image to know, is my user allowed to use this image, and there's other metadata associated with it that was required. And we went down the path of doing caching for that, ran into some issues, and then basically with the help of Glance PTL guys, I don't see them here, but the Glance team kind of participated in the spec review and ended up with this solution, which is good in the sense that it uses predominantly Glance capabilities that are already there today. So the way this works is that there's basically a full Glance deployed on each, at both the central cloud and all the edge clouds. It leverages the fact that Glance can support multiple backends and share backends. I show multiple backends here, but I suspect that the first way we'll implement it will be, there'll only be the one backend in the central cloud, and all the Glance solutions in the edge cloud will share it, and then they'll use the existing image caching in Glance that whenever it has a remote backend, it caches anyways in order to reduce latency transmission times on the next time the image is used. And then, so really the only extra thing we need now to do is to have the Glance database synchronized so that all the image metadata is there. And we'll do that in the next version of StarlingX using our sync framework again. Not sure if I'm running out of time here, but okay. And then I was going to show at least one demo. I'll show this demo first. So this is just a demo of the Keystone synchronization work that we actually did. I'm going to put my glasses on because I'm probably going to have to stop this because it's a quick demo. So again, this is synchronizing the Keystone projects and users using the new kind of, the additions to the synchronization framework for database-style synchronization. So I'm logging into StarlingX here as admin, and I'm logging into the central controller. I'm showing that I'm on the system controller as admin. I'll tell you this goes fast. So I'm showing that I've got a central cloud and one subcloud. It's a little uninteresting in the sense that there's one. What I'm going to show you first is, I don't know if you can actually see this, but I'm going to do a StarlingX system command to the central cloud as admin, just to show you, what's the system that I have there. And you can see the central cloud really just has a pair of controllers for doing, because fundamentally it's doing orchestration and management of the subclouds. Okay, now I'm showing you, the subcloud, I've showing you the IP address there, and I'm going to do the same StarlingX system commands on the subcloud, just to show you it's a different cloud. So that's just a system show command, and then this is a StarlingX host list. So there you can see that the subcloud is actually bigger than the central cloud. It's got 2 controllers and 3 computes, and then I'm going back to Horizon, and the Horizon's in this demo is always on the central cloud. I'm going to go to the Keystone panels, show you the projects and the users. I'm going to add a Wind River tenant and a G Wayne's user. So I'm just showing you that that doesn't exist. And what I'm showing you now is I'm doing a Nova flavor list with Wind River G Wayne's just to show you it doesn't work on the subcloud. And then, so now back to Horizon, to add the Wind River project and the G Wayne's user to the central cloud. So this will add it to the central cloud, and then, like I say, our sync framework will push that down to the subcloud. This is the only place where I get to breathe on the demo. So it added the user, and then I'm going to run the exact same command, Nova flavor list, on the subcloud itself, and you can see it actually worked this time. And then the last thing I do on the demo is just I show you the user ID of the user. You can memorize that, and now I'm actually jumping down in Horizon to the subcloud itself. Now you can see in the top left, upper left there, I'm in the subcloud, and you can see that it's the exact same user ID. And the only reason I showed that is that you can't set the user, or at least at one time, I'm not sure if you can now, but you couldn't set the user ID in the Keystone API explicitly, so it just demonstrates that we did use the database synchronization to sync that stuff. Okay, that's about all I had. The only other thing I had was just kind of a summary of kind of what we covered. James kind of went over the 2 architectures for reference 1 and reference 2, which were the, I think distributed control plane was the first one and centralized control plane were the others, and talked about the fact that we did some federated Keystone work in the Edge Computing Group around kind of testing that solution, and that was more along the reference 2 centralized solution. And then, like I've shown you here, the 2 activities in StarlingX for the edge computing was the synchronization of the Keystone and kind of getting the spec written for the glance edge caching. I think we're done. Any questions?
How does it handle quotas, the synchronization? Does it pick up all of the quotas for compute?
Yeah, today the way it handles quotas.
Sec. For the camera, the question was, how does the synchronizer handle quotas?
Right. Yeah. It's similar to the way Kingbird did. I don't know if you're familiar with that, but the quotas that are set are kind of at the central cloud are at a system level, and then kind of underneath the covers we manage the the quotas on the edge clouds. So like if the guy's got a quota of 10 VMs or something like that, then we'll manage them such that you can only do 10 VMs across the whole system as opposed to any one particular one. So it's very similar to the way Kingbird managed the resources. Yep.
How do you handle storage?
For storage at the edge, we recommend that they have the Cinder solution at the edge so that they're either using Nova local ephemeral storage or they've got a Cinder solution at the edge. And the edge could be like I had 2 controllers there. And in StarlingX release 1, basically the controllers could host kind of Cinder with a local volume manager on the controllers there. So we do support the ability to share kind of Cinder in like a Ceph cluster from the central storage, but doing that, you'd lose the autonomy and that sort of thing.
About super small edge where there will be no Nova process like Openstack?
Yeah, I should have mentioned that at the beginning. So what StarlingX has done, like kind of mapping it back to what James presented, was that it had the central cloud and then kind of that small medium one are the StarlingX edge clouds. And they're small medium in the sense that they have the full control plane. And although physically with StarlingX, that could be as small as a single server. And not only a single server, but like we deploy on like a low cost, low power server, like an 8-core Xeon D or something, and we can deploy like a full OpenStack. Right. So we haven't addressed, one thing we haven't addressed is the small edge in the architecture diagram that has like, is effectively only a compute node.
Yeah. So, I mean, and to be clear, so these 2 MVP reference architectures are specifically for those trying to deploy compute instances in the large, medium, and small edge sites. The question was, what if I have like a very small edge site that doesn't even have something like Nova Compute running there? So in this example, that's actually not part of the MVP. In this MVP, we're really talking about deploying compute resources at those large, medium, and small sites. If you're running an extremely small site where it's not even a normal like x86 machine, if it's some kind of appliance, that's just not captured in this.
Yep.
The other question is on the networking side. Like if you have different provider networks on different sites because they have different connectivity, how that is managed?
So the question is, what about the network model if you have different provider networks for different like large, medium, and small sites? So
Possibly different ISP, different kind of.
So where the networks are connected, possibly different ISPs. So I think there's like 2 parts to that question we can unpack. Like one of the questions is, if you don't have, if your very small edge site is say in some co-location somewhere or in some provider or possibly even over a 4G or 5G link, and then you have your medium edge site which has a fiber link to something. So that's one part of that question I can unpack. And in that example, that's more of a security concept and construct, but that is something that works fine, right? You can have your edge site run in a far site. And so even with hypervisors, we've seen that they can handle quite a bit of latency or packet loss talking to the message queue if it's in a medium or a large site, and they run fine. So that's kind of one half of that, right? And then the other half was, what about like managing provider networks in that model where if I've got a provider network in my medium or large edge site, and then obviously I'm going to have a different provider network in my small edge site. So in that case with Neutron, we look at those as being just different layer 3 domains. And so whether or not the layer 3 domain, the provider network for that layer 3 domain is in the main site, the medium site, or the small site, either way, it's a non-adjacent layer 2 domain. And so that's something that already works inside of Neutron with routed provider networks. Sorry. Let me answer his question first, and I'll come back. Ian's question is, what about tenant networks? And the answer is that is not currently handled.
Yes, I was going to say, you normally expect tenant networks to be accessible on all of your compute nodes.
Right.
You've got a very large cloud here.
Yeah.
But your network properties vary between those clouds.
Right. So he's saying that like if you have tenant networks, you expect them to be available everywhere, and then be sort of disconnected from the physical realities underneath. That's like the point of the tenant networks. In this case, we're not really handling that. And so if you have like SDN is something you could layer on top of this, but that's not covered in the MVP. Sorry, what was your other question?
I mean, it's on the similar lines, like, so in terms of provisioning multiple provider networks, you're going to be doing it central and push down, or?
So when provisioning multiple provider networks, would you do it centrally and then push down? So in the centralized model, I think you would actually define each provider network. Actually, why don't you answer for the centralized model?
Or, well, we really do the distributed model, but
yeah, I'm decentralized. Yeah, you guys say distributed. I'll answer for centralized.
Okay. Well, and, unfortunately, the answer for the distributed is we really haven't integrated the networking for the distributed cloud solution that we have. So the networking between edge clouds is really outside of any Openstack networking. So the connectivity would be done there. I mean, like that would be kind of a next step kind of work to look at the neutron networking.
Right. So basically in that model, like, each side is an island, but there's some federation. So there's some syncing and federation that happens to let them operate autonomously, but with common data set. In the centralized model, you create all the networks in the centralized control plane.
I should mention that if anybody's interested in additional StarlingX information, Jeff Gowan at the back can get you on a mailing list if you want to see him. There's a question over here. No?
Oh.
Is vision of StarlingX the same as Openstack vision?
The question, I believe, is a region in StarlingX the same as a region in Openstack?
Yeah, they're exactly the same. Well, StarlingX is an OpenStack pilot project, so it is available through the StarlingX project. Well, the model that we have now is that the sync framework is in kind of StarlingX, and then there's kind of service-specific plugins to the framework in StarlingX to enable the synchronization of the different services. It could be something that one option is to I don't know if we've considered, but is to kind of could potentially separate out some of the distributed cloud stuff from StarlingX and make it available. Like maybe the sync framework would be a possibility to make that available independent of StarlingX, but the other approach is to kind of leverage StarlingX to get that capability. Yep.
Sorry, this gentleman has his hand up.
Sorry.
So thanks for that. Thanks. It's really good to see things progressing. Thanks for that. My question is regarding the GP synchronization. So maybe I missed the beginning of the presentation, so maybe it's already here the answer. But I'm wondering how you can maintain. So let's consider tomorrow you have 10,000 small medium sites. Okay, so that means that you have to synchronize 10,000 DB. So basically you explain that you are a lazy approach, so you will create the role of the tenant only if needed. Mm-hmm. But are you keeping kind of global knowledge? For example, if you want to delete the user, if you want to divide the tenant?
That's a good question. So the question is, for using that federated Keystone model, and I like the expression, like the kind of lazy creation of users only and tenants as needed. And then what do you do if a user is terminated or something like that, right? So that's a good question. So in that model, the way that works is that when a user goes to connect, they actually call this IDP, and they get a very, very short time-scoped token that they're able to use to call Keystone. Keystone then returns a Keystone token to them for them to use when talking to the cloud. So in that model, if a user account is terminated, then that means they can no longer fetch an IDP token. And then in turn can no longer fetch a Keystone token. So this is kind of one of those interesting things with asymmetric authentication, is to say, like, do I have certificate revocation? And if so, that means that every time I make a call to validate a token, I need to check a revocation list, so that there's a hit there. So we've chosen to take the path of saying that we will manage that risk with shorter token lifespans and say we'll only accept a token that's good for within, say, an hour or so. So by doing that, you can actually say that if a user account's terminated, then within an hour, they'll no longer be, if they got a token and then they were terminated, they then theoretically do have access for an hour, but we find that that's an acceptable risk. Otherwise, if you want periodic cleanup to remove deleted or terminated users, that's a separate thing you could do monthly. Again, to one of Ian's earlier points in a previous thing about spending all those cycles, right? By doing a periodic janitorial task to clean up terminated users monthly, you're not spending a lot of CPU power in these edge sites as opposed to kind of hammering at them. And so that's why that particular version of the architecture could be good for deployers that are looking to run many tens of thousands of edge sites. Sorry.
Oh, okay, so the StarlingX release 2 that's going to come out in a few months actually uses Kubernetes as its base layer. So we're changing the our OpenStack solution to be a containerized solution, as opposed to in release 1 we deployed OpenStack on bare metal servers.
Sorry, what was the question?
Yeah, the question was just what role does Kubernetes play in StarlingX?
Gotcha. Cool. All right, if there's no other questions, there's one more. Yeah. Sir?
So back to quotas, how does the IDP model work with quotas?
In the IDP model with quotas, you set the quotas on the, so for the centralized model, so IDP is only for identity. Quotas are not part of the identity thing. So in the centralized model, you set quotas via your central tooling on each cluster as on each large geographic site as you see necessary. And for the distributed model, I'm guessing you set it on within the edge site, right?
Yeah, and yeah, I think that was the question originally asked, was so we manage the quotas on the edge sites to kind of effectively have a system-wide quota.
So if we're doing the IDP model and the user has access to an edge site, there's no way of knowing what quotas they have, right? They have to start instances.
So with the centralized model, the user talks to the large regional data center, is the site they communicate with. In that model, in theory, they could get that same, so in that model, they talk to the large regional data center, they get the information they need. And that's why that's the one that has lower operability cost, but it also has less autonomy during a network partition. So if the edge site can't talk to the main site and a user's in that edge site, they're not going to be able to fetch the quota. In the distributed example, a person could be in an edge site and still talk to their local Keystone and get the quota.
Yep.
Hi, probably quick question. I might have missed it, but in the work that you've done getting up to, let's say, release 2 kind of time frame, are you targeting a use case like 5G, or are you thinking more generically? Like whatever distributed cloud the end user actually has?
Yeah, in theory, it's applicable, to any application that requires distributed cloud. But yeah, 5G is definitely a front runner application in that sense.
Yeah, I guess I was wondering are there any that are feeding in directly requirements to say, if if it's going to work in this environment, you need to do this kind of thing?
I think I know Beth Cohen is in the Edge Computing Group is kind of developing use cases, and I think she is kind of working with potential users of the two MVP architectures. Yeah.
Got it.
I think we're about out of time, right? So thank you all very much. If you have any questions about StarlingX, talk to Greg or the other gentleman from Minerva. I can talk about general questions about the architecture if you're interested.